Okay, today we're going to be talking about topic 10-6, the last topic in Unit 10. And it's just more of using our three triangle congruency postulates with our CPCTC. And sometimes taking it a step further. But if you'll notice, today's proofs are just a little bit longer. Let's go ahead and jump right into this first one. I'm going to start by labeling my picture BC parallel to AD, and AB is parallel to CD. Now, somehow I've got to get three congruency statements between these two triangles to prove that they're congruent, so that I can prove that these two angles are in fact congruent. So let's start with the first one. We know that BC is parallel to AD, and this was given to us. Let's go and extend this parallel. And what do you know? We have a transversal here. Now with the transversal, I've got this angle and this angle being alternate interior. Now, it's very important that you notice that the angles I'm marking are touching these lines that I have extended. I'm not talking about DCA. I'm not talking about this angle. I'm talking about angle BCA with CAD. These are opposite and touching my parallel lines. So angle BCA is congruent with angle CAD, and these are because these are alternate interior angles. Well, I've used that statement, gotten a congruency. Let's see what else I can find. So I'm going to go ahead and clean this up just a little bit. Because I want my next step to be very clear. Here, I'm saying that AB is parallel with CD. And just go ahead and relabel this one as C. This one is A. I want to make sure you know the points. Now here, I'm dealing with this angle, which I'm going to mark with 2 marks, and this angle, which I'm also marking with 2 marks. These are alternate interior angles, okay, but they're formed between these parallel lines and the transversal. It's very important that you get these right. So I'm saying that DCA is congruent with BAC. And I'm saying because of alternate interior angles. Well, hopefully you didn't skip what I did and you went ahead and wrote given here, because the statement was in fact given to us. And we have our congruency statement, so we are done with that particular given. All right, are we using side, side, side? Are we using side angle, angle, or angle, side angle? Well, I've got 2 angles, which means I need a side in between. So I need a side in between these angles. And what do you know? It's this one. AC will be congruent with itself, and that is our reflexive property. And I've got my 3 congruencies, so I can say that these triangles are congruent because of ASA, angle, side, angle, angle, side, angle. I need to make sure I name them correctly. So let's count down in arcs. 2 arcs to 1 arc to no arc. That would be A, C, B. 2, 1, none, C, A, D. Okay? 2, double arch, single arch, no arch, double arch, single arch, no arch. Just want to make sure I get them right. Because now I need to be able to say that angle B is congruent to angle D. They're both the last ones in here, so I know this. It's also my proof statement. I know this because of CPCTC. So these proofs require a little bit more thought than the ones from the last topic, but it's still not including any new information. Let's take a look at example number 2. Well, we know that AB is parallel with ED. We know that C is the midpoint of BD. Well, let's get to it. Let's go ahead and mark the first one. AB parallel to ED, given. And we're going to go ahead and work with this one. Even though I kind of see a congruency statement already, it's based off of the second statement, and I'm not ready for that yet. Let's go ahead and work this. Well, extend my parallel lines out a bit. And I've actually got a pair of transversals. I like to have everything touching, so that means let's go ahead and solve for these angles. So let's use this transversal. Because, just pointing out, that if I get these two angles to be similar, these angles are opposite of the respective sides that I know to be congruent. And I don't have anything that deals with opposites. All I have deals with including. So I need to make sure that I've got either angles on both sides of this or opposite sides of a shared angle. And because I can find an angle relationship between these, we're going to find these angle relationship. So I'm going to mark my two angles, and I can really quickly name them angle B, congruent with angle D, because they're the only angles represented. And I know this because these are opposite sides of the transversal inside the parallel lines, alternate anterior angles. Got my congruency statement. Need the second one. C is the midpoint of BD. This was given to us, and we've already marked it that BC is congruent to CD because of the definition of that word midpoint. We've got our second congruency statement. Now I need something. Well, I know that I've got either side, 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 angle, side, or angle, side, angle. And I'm using an angle, so I can't be side, side, side. So I either need to prove that AB is the same as DE, or I need to prove that these two angles are the same. Well, these two angles are vertical, so yes, they're the same. Angle BCA congruent to angle ECD because they are vertical angles. Now, I couldn't just use angle C because I've got 1, 2, 3, 4. I've got 4, 1, 2, 3, 4 different angles here that all use C. So I had to label them out. But I've got my congruency statement. 1, 2, 3 congruency statements. I can call these triangles congruent because of angle, side, angle. Now I need to name them. Well, this time, again, it doesn't matter what order the first one goes into. Let's say alphabetical. A, B, C. Well, A has no arcs. Neither does E. B has a single arc. So does D. And C has two arches. And you know what? It's still C on the other triangle. I need to figure out what to put here so that my next statement can be that C is the midpoint of AE. So let's think. I want C to be the midpoint of AE. That means that we've got to cut this in half. So now I'm not working forward anymore. I'm actually trying to work backward. I need to prove that these two are congruent. Well, I know that they're because these two being congruent would tell me that C is the midpoint. And I know that these two are congruent because of CPCTC. So AC congruent to CE, CPCTC. I know that I've got congruent parts because I've got congruent triangles. And AC with CE. So, C is the midpoint because of the definition of that word, midpoint. Now, I want you to notice, CPCTC was not our last reason here. And the last topic it almost always was. Here, you have to be a little more careful. Sometimes CPCTC is what you need to get the next piece of information. So, you're still going to use it in every proof for this particular topic, but it may not be the last one. Moving on to our third and last example. Let's go ahead and start with our first given. S is the midpoint of TV. This was given to us. S is the midpoint of TV. That means that these are the same. So I can go ahead and mark that TS congruent to SV because of the definition of a midpoint. Now I know that TR is congruent to VR because this is given to us. And I need that third thing. Well, again, we have our options. We have side, 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 angle, side, and angle, side, angle. Well, I've got two sides, so we know it's not that one. So I either need to prove that T is congruent to V, or I need to prove this third side. Well, my third side happens to be here, and we know the same place. Well, it's reflexive. So RS is congruent to RS. And this is our reflexive property again. And we've got our three congruency statements. We use three sides. So we know this is S, S, S. And we know that two triangles are congruent to each other. Now, doesn't matter for the first one. Let's go ahead and go alphabetical order. Q, R, S, T. Now I need to do the next one. Well, I used RS as my first side. So I need to use the corresponding side for the other one, which happens to be RS. Next I used ST. My corresponding side with ST would be SV, because I'm starting with S I need to write the other letter, which is V. Which would mean that RT has to match RV, and it does. They're both the double tick marks. All right, so we've got this, and we need to figure something out. Well, pretty good idea that we're going to use CPCTC. I just don't know what for what, but I want to get to this statement. I want to get to the point that SR bisects angle TRV. Well, TRV is this angle, and bisecting means that I cut it in half. So that means that this angle has to be the same as this angle. So TRS, so angle TRS, needs to be congruent with VRS. And they are because of CPCTC. So we're good. Now I gotta find this last reason. Well, I said that these two angles are congruent, and my statement says that they bisect. So this is the definition of a bisection. Whenever you see the word bisect or midpoint, know that pretty close you're probably going to use either the definition of midpoint or the definition of a bisector. Here we use that definition afterwards. Here we use that definition at the same time. It just depends on when it comes in your statement and what you're trying to do with it. So, take time, make sure that you give a lot of thought to these proofs. Again, CPCTC is going to be used because that's what the packet is about, but it probably won't be your last statement, and you may need to work backwards. Well, good luck on the assignment and have a good day.